Okie dokie, artichokes, let's get started. So first things first, I'd like to correct something I said in the first video. Balto didn't actually die when he made it to Nome. He actually lived to the ripe old age of 14 and died in 1933. So, that should make all of you dog lovers very happy. I apologize for that misinformation on my part. Okay, today in the lesson, the point of the lesson was to get you introduced to the idea of something called point of intersection, which is a pretty self-explanatory concept. It's literally the point where two lines intersect, point of intersection. So, where two lines cross on a graph. Ms. Schmidt is going to teach you in the next couple, I almost said episodes, the next couple lessons, how to recognize the point of intersection in a table and also in equations. But today, I'm teaching you point of intersection via graphs, which I think is the easiest one to look at. So we have 4 graphs here and 4 different situations, and you're going to tell me via Nearpod what you think each point of intersection means. So we're going to start with A. I'm going to read this to you because I'm not sure you can entirely read it. So what we have is a graph. The x-axis is time of year in spring, and the y-axis, sorry, my purple writes better, is temperature. So time of year in spring and temperature. So what we have here is we have San Francisco. San Francisco, early on in the spring, has a really low temperature, and then it starts to climb as we get closer to summer. Rio de Janeiro, though, and I could be saying that totally wrong, and I'm sorry, starts off with a really high temperature at the beginning of spring, and then as we get closer to summer, it starts to drop. Okay, so what I want you to tell me on Nearpod is, what does the point of intersection of these two lines mean? Okay, let's see if you got this one right. The point of intersection of these two lines means that at this point in the spring, both Rio de Janeiro and San Francisco are the exact same temperature. Bonus points to anybody that can tell me, and I will give you candy in your bag, why Rio de Janeiro goes down as we get closer to summer. I'm not going to tell you the answer to that one. You'll just have to find out later. Okay. B. So what we have on our x-axis is number of tortillas manufactured, and then cost to produce is on our y-axis. So if we take a look, we have 2 lines. We have handmade. So the handmade stays nice and steady. So the cost to produce is the exact same no matter how many tortillas are manufactured. The machine-made, on the other hand, starts out really high to produce, but as you make more and more and more, it starts to reduce, which is kind of how that works. It's why you buy in bulk, right? Because the more you produce, the more cost-effective it happens to be. So, what you guys are going to tell me is, what does this point of intersection represent? Okay, hopefully you told me that this point of intersection represents where machine-made and handmade tortillas cost the exact same amount for the exact same amount of tortillas. Okay, so we could say this is like 100 tortillas. So 100 tortillas cost the same to make in a machine and handmade. So eventually, as you can see, the machine-made is going to be more cost-effective. It's a lower cost here, the more tortillas you make. So that was B. Number C, as you can find out, as you can see, the blue really is a terrible drawing utensil. So on the x-axis, I have population. On the y-axis, I have pollution. So as we're looking at, let's say, Boston first, which is my green line, Boston's population at 0 has 0 pollution, but increases what we call exponentially, this really steep curve here. Increases quite quickly as the population grows. The pollution goes up and up and up and up. If we take a look at Denver, Denver starts out with quite a bit of population, or quite a bit of pollution, even with a very small amount of population, and tends to stay pretty steady Like, it is increasing, but very slowly as the population grows. So the pollution to population is not that terrible. So what I want you guys to tell me is, what does this point of intersection mean? Okay. Hopefully, you guys told me that at this point, both Denver and Boston have the exact same amount of population and have the exact same amount of pollution at that specific point. Okay, that's the point of intersection. Same population to same pollution. Okay, so on our very last one, D, we have time on our x-axis, and on our y-axis, we have distance from starting line. If you don't know the tale of the tortoise and the hare, it's where you have a rabbit and a turtle, and the turtle and the rabbit are racing. So naturally you'd think the rabbit's gonna win. Well, the rabbit races ahead of the turtle, gets tired, and decides to take a nap because he's so far ahead of the turtle. Well, at some point, the turtle passes the rabbit while he's sleeping and ends up winning the race. Just a lesson to you, never underestimate your opponent. In this graph, we are looking at the tortoise and the hare, or the turtle and the rabbit, in their race. So, naturally, the tortoise here starts out exactly when the race starts. And he's very slow and steady. He is very slowly gaining distance away from the starting line. Okay? The hare, the cocky hare, thinks, oh man, that turtle's so slow, I can like start whenever. So he starts quite a bit after the turtle. And because the rabbit is much faster than the turtle, he gains distance very quickly. So his line is considerably steeper. Okay, so what I want you to tell me is, what does that line right there represent? Or what does that point of intersection represent? Sorry. Okay, hopefully you told me this is the point when the rabbit and the turtle cross paths, right? The turtle has been going, and at that point the rabbit passes him and continues on to finish the race. Although we know at some point he'll fall asleep and the turtle will win anyway. Okay? So points of intersection on a graph, like I said, very easy concept. If you struggle with it, please ask questions. It's one of those concepts where you either get it right away or it's like pulling teeth to understand. So if you don't understand it, please let me know. Something that Ms. Schmidt will bring up, and I just want to point out before you get there, point of intersection, I don't know about you, is really annoying to write, especially when you have a graph that has numerous points of intersection. So from now on, instead of having to say point of intersection every single time and write that out, Ms. Schmidt and I are going to refer to this as a POI, point of intersection, or POI. So when I ask you, what are the POIs, you know I'm asking you for, what are the points of intersection? And there you go, that's the lesson. Very nice and quick and easy. Please ask me if you have any questions on POIs. Have a great day, everybody.